Welcome to the Future of Life Institute podcast. I'm the new host, and my name is Gus Docker. The nuclear arsenals of the world are controlled by complex systems, and if these systems fail, billions of lives around the world are in danger. So, on this episode of the podcast, I talk with Philip Reiner about what he's learned about these systems throughout his decades long career spanning the White House, the Pentagon, and now as CEO of the Institute for Security and Technology. We talk about how these systems work, how they might fail, and what we could do to improve them. Towards the end of the episode, Philip also shares his thoughts about what's going on in Ukraine and what this means for nuclear risk. Philip, welcome to the podcast.
Thank you for having me. It's great to be here.
What are NC3s?
All right. So it nuclear command, control, and communications, right? So NC3, this is actually a fairly American way of referring to the systems that are in place that allow for the management of nuclear operations. And so it's really, NC3 in and of itself is a very American characterization of what all nuclear weapon states have to maintain in order to ensure that they are, one, able to utilize their nuclear arsenals when they need to, but then also that those systems won't be used for nefarious purposes when they aren't, right, being turned to for actual nuclear deployment. So it's fairly complex. Really often what we describe it as is the fourth leg of the nuclear triad, where you've got um, the elements that actually, so NC3, probably the easiest way to summarize it is that NC3 is the means by which presidential authority is executed. And I think it's really important to note here, right? As an American, as a former Pentagon official, as a former White House official, that is the way we think of it here in the United States. Other nuclear weapon states don't necessarily think of it in those same terms.
How do other states think about NC3s then?
Yeah, it's very much dependent upon the nation and the kind of the history and the culture that we're thinking of, right? Each approaches it in very much their own way. Um, I think it's also worth noting, actually, if you look back at the history of NC3 in the United States, you can find probably 15 different variations on the characterization, right? Where it's NC2, it's NC3, it's NC3I, it's N3, NC3I, all of these other acronyms that clues in all of the different components of what goes into the system of systems that is NC3. I think it's very much contingent on, for instance, you think about, I'll give the example of the UK. They have a submarine-based deterrent. Their NC3 is going to be vastly different than that is what is required here in the United States. If you look at, say, Pakistan, smaller arsenal, much different command authority in terms of who's actually in charge of the maintenance and utilization of these things in the lead up to a conflict, military versus civilian. All of those sorts of elements result in a different command and control architecture. I would argue that the United States probably has, I think it's safe to say, one of the most sophisticated and complex systems of systems when it comes to NC3. And, we've done some work on this at IST. It's, we've seen that there are over, 200 different systems within the NC3 system. And so when you speak of NC3, it's not one monolithic thing, right? It's actually all these other incredible components, right? Like signals processing, data analytics, lots of the communication element. So it's very different, say, for North Korea, right, which is only a nascent nuclear state where, again, they haven't had the decades of thinking through these sorts of challenges like the United States has, or say Russia has?
When we're thinking about the technology involved in NC3 systems, what technology is involved at this point? Because I think I have heard or read rumors that the technology involved is often very old, but that
Yeah.
there might be reasons for having old technology.
Yeah. Yeah. And I think that's it's an interesting conundrum, right? Where you find, so in the United States, over time, there has developed a command structure where you've got US strategic command has leadership and ownership of vast components of the NC3 architecture. And at the end of the day, manages our nuclear forces, right? I have heard a strategic command commander say that at this point in its history, the development of USNC3 might necessitate a reversion to analog in certain elements because of the risks inherent to going digital, right? Anybody who spends time in this domain, we uh, we often assert, and I think it's fairly commonly accepted at this point, assume breach. If you have digital systems, they're vulnerable. It's almost an inherent element from the silicon all the way up, that someone is going to find a way to mess with it or break into your systems. And so, when thinking about something as sensitive, right, something as inherently dangerous as nuclear weapons, you have to very carefully think about what you're going to digitize, whether it's the communications elements or whether it's the actual command and control elements. Now, some countries have more um, resources when it comes to that sort of thing, right? When you think about, um, say, again, Pakistan, they may have the imperative to move much more quickly towards systems that give them more immediate capability without having the luxury, right? They feel that imminent risk. They perceive that imminent risk from India. So they'll move down a path that allows them to be able to perhaps necessitate their digitization of their system so that they can be more able to move quickly or communicate more rapidly. But what has that created in terms of the vulnerabilities inherent to those systems they rely on? So there is a real trade-off and analysis that needs to go into um, any sort of command and control architecture. Now, goes without saying, right? Any system that relies on uh, legacy components is going to need to be not only maintained, but probably be retrofitted, updated at some point. And so what we see in the United States is, and I think this goes for Russia very much so at the same time, this is a vast architecture that was developed over the course of decades, right? Since the early 1950s. And many of the integral components of this, as the combatant commander has talked about publicly, aren't up to snuff. These components aren't being built anymore. You can't update something that's degrading in its effectiveness or in its functionality if no one's even building those parts anymore, right? So, what's your which way do you head with that as you think about um, the fact is, right? You need to have this system needs to be available to you at all times, right? This is that always never paradox with nuclear weapons, right? They always need to be ready for you to use in the case of a crisis where you need to actually potentially deter an adversary, but you never want them to actually, be used nefariously. Um, and I think that's often when folks talk about nuclear weapons, they skip right past the NC3 piece of it, which is almost, if not more important than any other element because of some of the questions you just asked. When it comes to the technological element, I think, much of the conversation that we've been involved with lately uh, is around machine learning, is around deep learning and its potential role in modernization of NC3 architectures. I think uh, there's much debate around not just the integration of those sorts of capabilities, but also the automation of certain decision elements within an NC3 architecture. That's a Yeah, it's a very rich debate that gets back to the technical. at its core, very, very much so.
I'm wondering whether there are trade-offs between speed of implementation and security of the resultant system, of the system that we built in the end. So you mentioned the dilemma of that
Yeah.
Pakistan is in, where they are building up capacity, but do not have the, we could call it, luxury of building out security in the same instance. So, how do you think about this trade-off between security and speed?
It is um, a lesson that we've discussed in great detail. For instance, with a counterpart of ours, the former head of security and privacy at Google, Eric Gross, who reminds us all of this adage of complexity is the enemy of security. And these NC3 systems are so incredibly complex that even the commander, right, of U.S. Strategic Command has noted publicly that even he doesn't really understand how it all works. Like looking at the vastness of the system and understanding all the interconnected components. At the end of the day, though, even 20 some odd, 30 some odd years ago, I think you had the U.S. National Security Advisor publicly saying he had 3 minutes to figure out what he was being told and to take it to the president, who would then have 4 minutes. And that cycle, that time compression has only intensified over the years since then. So that question that you note of speed, right, is absolutely an imperative in a world where those sorts of risks um, are what you face. I think a lot of the work that has been done and it continues to be pushed now is how do we actually extend those time cycles? How do we actually build in more space so that those decision makers can actually have more freedom to think and just debate and not have to rush to deploy or potentially even use these. And so it's a real conundrum, right? Because you have to have these systems in place in order to move quickly, the quickest, right? You have to be able to move faster than your adversary. And let me come back to that. It's not just to maintain an advantage, right? So let's come back to that in a second. Um, but you also need to take into account um, that piece that you were talking about, right? Where if you're moving quickly down the path of adopting these kinds of technologies, that you're actually making yourself less safe. You're actually making the entire dynamic less stable.
What could be an example of moving too fast so that you're making yourself less safe?
Well, I think um, a very clear example that one could point to is um, Russian indications that they're moving down the path of having an automated, autonomous nuclear torpedo, right? And the realistic nature of those technologies and whether or not they'll get to a point that they can develop it and deploy it is a debate. I don't know that that's necessarily. Look at Ukraine. Some of what everyone assumed Russia was going to be capable of was actually a bit of a paper tiger. Um, but their insinuation, right, is that they want to be able to move down that path so that they can have something that's basically on not only hair trigger, but it's off of the United States coastline. It is an immediate nuclear risk to U.S. not only military but also civilian infrastructure. That speed, that tightening of and the coupling of all of those decision making elements is, I think, their reaction to what they see as a disadvantage vis-a-vis the United States technologically and even more broadly, right, economically, et cetera. And so they'll revert to the adoption of these capabilities so that they can get inside of our decision cycle. That's inherently destabilized. That is inherently putting them. So that then forces, and we saw this play out in 2018 as this, I think it was 2018 where this became public, 2019. The US then starts to make changes in order to react to that sort of behavior on the Russian side, which actually probably at the end of the day makes Russia less safe. We're going to take steps in order to remove the threat posed by that system. Um, To what we were saying a second ago, right? In terms of the importance inherent to these things. One of the lessons of the Cold War was the ability to actually communicate with your adversaries. So the United States and USSR at the time were able to actually have in-depth conversations and understand to a great degree what the other was capable of, right? And so the speed at which you could move was something that you actually discussed and put on the table. And there's a reason for that, which is that I am looking to deter you from moving first, right? Bolt out of the blue nuclear strikes are not something that folks really are super worried about today, but this was a very real, I mean, it's very realistic back in the day, right? Where bolt out of the blue, meaning like someone who could just unknown, like out of nowhere, strike you and basically wipe you out so that you have no ability to strike back. There is an imperative, right? And it's somewhat counterintuitive. There is an imperative then, if you're the United States or Russia, to be able to prove that you can survive a nuclear strike and strike back in order to deter said, first strike inclination. Yeah, that's messy, right? Like you're basically telling me that you need to have more nuclear weapons in order to prevent nuclear war. And you need to have the systems in place in order to ensure that not just have the nuclear weapons, right? But ensure that those weapons will work after there's a nuclear strike.
When
Yeah.
you update and maintain these systems, you then incentivize other states to also update and maintain their systems in a cycle of escalation where no country is interested in escalating, but all countries are incentivized to escalate.
Which is a this is the security dilemma, right? I do, this is, goes back thousands of years, right? I do the things that I see that are going to make me safer, but in the end, they actually make me less safe. It is um, this is not something that's ever been solved, and I don't know that it ever will be. Right? I think what's interesting about it, C3 though, that is often overlooked though, is if you head down that path, it is a bit of a contradictory scenario. But if you are able to head down a path, and I'm convinced of this, where you can actually show that your systems are reliable and resilient and that they do the things that they're supposed to do, that is actually inherently stabilizing. That is actually let's say if you're India and Pakistan and there isn't a whole lot of clarity as to how the systems will perform and whether decision makers will be able to rely on their systems when they need to, that is an inherently destabilizing reality. And so you actually want states to be able to move down a path. And again, not everybody uses the characterization of NC3, but I would argue we should really do everything within our power to ensure that states have these capabilities so that that risk of initial use goes way down. It's even further kind of counterintuitive, in my opinion. I think that this is often, again, not something that's discussed very broadly. NC3 systems, incredibly reliable NC3 systems, actually could help reduce nuclear arsenals. So we could actually see a world with less nuclear weapons in it if you can actually make sure that these NC3 systems are actually going to work in the way that they're supposed to. If you think about at the end of the Cold War, that was one of the things that actually allowed for some of the dramatic reductions in nuclear warheads, because you could point to systems that would actually be more reliable and more resilient. Therein, you don't need as many weapons, right? Because you've got this arc. It's actually a confidence building measure, which is entirely counterintuitive at first, right? Really, you're going to build out your ability to effectively and precisely use nuclear weapons. That's a stable one. Yeah. Yeah. It can actually be inherently stabilizing. So, that's one of the reasons why you look at something like, or the situation, for instance, in North Korea. One of the reasons why it's so frightening is they don't have these sorts of systems. They don't have the command and control and positive and negative controls that we would really hope for in a nuclear weapon state to make sure that things don't go wrong, that those accidents don't happen, etc.
Are there ways to selectively enhance safety in NC3 systems as opposed to enhancing both safety and capability?
Yeah, it's a fascinating question. I think, yeah, absolutely. Yeah, I think there are both positive and negative controls that can be decided upon that will improve the credibility and the reliability of these systems without necessarily giving um, some sort of military um, capability that would be destabilizing. Yeah, absolutely. I think um, there's lists of things that you could go through, and that could be part of a confidence building exercise. And I think the United States and Russia, or excuse me, the United States and Soviet Union went through that back during the Cold War, where they actually had discussions about what are the types of things that they were working toward and what would they stay away from. Absolutely, I think that is possible. I think necessity is the mother of all invention, right? Um, that was because there were, tens of thousands of nuclear warheads pointing at each other. And it was, an imperative to have those dialogues. A lot of that sort of political space is a little bit harder to imagine today. Um, One could take the unilateral steps of heading in that path. I think to a certain degree, the United States chooses to do so. Um, it's somewhat further afield, but I think it's a good example of the U.S. unilateral announcement that they would not develop ASAT capabilities. These are the kinds of things that could factor into, because that's, at the end of the day, that's part of your command and control architecture, right? And your satellite, your infrastructure.
What are these capabilities you just mentioned?
In terms of the ASAT testing,
Yeah, yeah.
well, this was a unilateral move on the United States' part. It was actually announced by the vice president that the United States, if I'm getting it right, the United States would not pursue the development of anti-satellite technologies, right? That we would um, take off the table the development of our ability to knock others' satellites out of, to destroy their satellite infrastructure. We've seen rather um, sophisticated moves in that direction by the Chinese, by way of example, in recent years. And so this was a move on the United States' part to say, we're going to set a norm that actually moves in the opposite direction. There are those within, I think, the US system who would very ardently argue that that's incredibly risky to unilaterally move in that direction. But the Biden administration has done so and is now working, as far as I understand it, working very earnestly at the UN to establish this as a norm that others are supportive of, to try and move away from that because of all of the risks inherent to having those kinds of technologies.
These unilateral de-escalation moves, are they a general solution to the security problem?
It's one tool, right? It's one means of um, engaging in these sorts of confidence building steps. There's unilateral, there's minilateral, there's multilateral, there's bilateral. There's a broad variety of ways that you can try to come at these sorts of dynamics and put ideas on the table that will help reduce pressure, reduce risk, enhance trust. I think this is what allowed things to what allowed for avoidance of nuclear war during the Cold War. It's one of the things. I'm someone who has spent a large chunk of my professional career working on South Asia, so in India, the India-Pakistan dynamic, and finding CBMs in that space that both nations are able and willing to talk about. It's been years since you can even get that stuff on the table. It's tough.
We should talk about the communication part of NC3. It seems to me that communication is an almost pure good in these situations. If states can communicate more with each other, that seems perfectly great.
Yeah.
What do you think of that? Is it the case that more communication is always better, or could there be downsides to having states communicate more effectively with each other?
One of the things that we have spent a great deal of time on at IST is thinking about crisis communications and crisis communication solutions. And this harks back to something I mentioned earlier from with Eric Gross from the former security head from Google. Something we've been thinking about is this CATALINK system, which is it's an attempt to pivot off of this idea that complexity is the enemy of security. So how do you actually build a very robust, resilient communications capability that is available to all nuclear heads of state to avoid crisis? And so this, I think, for your question, this is predicated off of the hypothesis that the ability to communicate with one another is absolutely a good thing. I think the history of hotlines, if you go back to nuclear hotlines, right? There's all sorts of different types of hotlines. There's military to military hotlines. There's all sorts of different types of hotlines that historically have played a role in reducing conflict. But if you think about nuclear hotlines, you can look back to what happened after the Cuban Missile Crisis and the U.S. Soviet hotline that was established after that. There were times when political actors attempted to use that hotline in a negative way, where they attempted to manipulate it and manipulate their their counterparts. So, there's an element of trust here that is really necessary for those communications channels to be effective. If you um, if you also look at the current dynamic, say with China, they want to pick up the phone. So even if you do have the system in place, it's trusted, it's reliable, secure. The folks on the other end need to be authorized to actually pick up and speak or communicate, whatever, text based or phone based, whatever it might be. Without a doubt, the ability to communicate with one another reduces risk. The ability to actually understand where the other person is coming from reduces risk. I think I always look back to my time at the White House when, we would go through cycles where we wouldn't be able to meet with our counterparts and, would go months, 6 months at a time. And just being able to go sit down with your counterparts it would just change this dynamic almost immediately. Um, you look at how long, for instance, Xi Jinping from China didn't leave the country. That's incredibly worrying. Where you have got to be able to sit down, you've got to have communication. And in today's world, there are all sorts of different ways to communicate with one another. I think relying on, WhatsApp may not necessarily be what you want nuclear heads of state, turning to in order to communicate with one another. So that's why we've come up with this idea of Catalink. Maybe that could be additive to existing command and control system, additive to existing communications capabilities. But without any doubt, yeah, having the ability to communicate with one another is absolutely essential to reducing risk.
Could you tell us more about the current situation of communications between nuclear states? Is it actually the case that they are communicating using WhatsApp?
Well, I think um, there's all variety of different, secure messaging platforms that folks have become reliant on in both diplomatic circles and elsewhere. I, WhatsApp tends to be the one you hear most often about folks, engaging in conversation via. I think um, there is a a real challenge in terms of there's the day to day. There's intense, diplomatic negotiations that may be happening over those types of platforms. But then there's the level of things that we're talking about when a crisis may actually be maybe brewing, and what sorts of communications capabilities do you have in place? And there is a very reliable hotline between the United States and Russia. It is not only at the head of state level, but there are means of communication for potentially the Secretary of Defense for the United States to talk to his counterpart. Um, what we've seized upon in this um, current situation, current reality, is that those tend to be those are solely bilateral means of communication. but we don't live in a bilateral reality. So if there is a potential nuclear crisis like what we've seen kind of as a result of what's going on in Ukraine, that is not a US Russia problem. You've got two other nuclear armed states in the midst of that situation with France and the UK, not to mention the fact that China is almost guaranteed to be a part of that um, situation if Russia were to actually use nuclear weapons against Ukraine. How are all of those states going to be able to communicate with each other? Well, it's all bilateral, if at all. I think one of the very interesting things that was brought to our attention was that the ability for even for NATO, Russia, and the UK, or NATO, Russia, and France to be able to communicate with each other simultaneously doesn't exist. You think about that, right? You've got a group chat on Signal with folks in 7 different countries, and you guys you can have a totally encrypted, no one's ever going to know what's in that discussion means of communicating with each other, but we currently don't have that means for heads of states with nuclear weapons. It's beyond simple to get after that challenge in our opinion. Right? So I think, folks may default to WhatsApp because it's what's in their pocket. So why don't we work on giving them something else that they can rely on that's more secure and robust and dedicated, right? Distinctly built and dedicated to this sort of challenge because, maybe WhatsApp and Signal serve a purpose on the day to day, but we'd need something a little bit more um, like dedicated and robust for these kinds of challenges. That's what the CATALINK system is trying to get after.
Let's walk through the different parts of the CATALINK system. And maybe you could tell us what the different parts of this system, what problems are solved by these parts.
So the basics, right, of CATALINK is really 3 primary components. There's a device, we call it the puck, and that's the communication device that you would rely on. It's a basic text-based messaging capability that is built from the bottom up. Again, this notion of complexity is the enemy of security. Having worked with folks at Google and Intel and elsewhere to think about how do you actually build something from the bottom up, from the silicon up, that is actually verifiably secure. So that's the puck. Then there's what we call the broker. So this is the interface from through which the signals from the puck would be translated into whatever sort of communications network you're relying on. And the way that we're designing this is so that, that is very flexible, that you can actually determine through whatever mechanism you want those messages to actually go, whether that be satellite based or cell based, or what have you.
So there's redundancy in the network that transmits these messages.
Inherently, this is where it gets most interesting, though, right? And incredibly challenging in the event where you actually have an exchange, a nuclear exchange, or even in the lead up to an exchange. What you'll see in most planning, and you saw this to a certain degree just with Ukraine, communications architectures are what are going to be targeted first, almost 100% of the time, whether that be the satellite network, the cell towers, the internet. The ability to get information through is going to be one of the first victims and lead up to any conflict. So if you're relying on this multinational CATALINK system, what is your fallback for if and when those other options are not available to you? And that's the third component that we've been working on. We call it the rocks. The intention is to build out a mesh network that will be available when everything else fails. And so that is honestly, it's an incredibly complex technical challenge to get after. It's something we're working on. We love to hear from people who work on these kinds of things already and who would be interested in playing a part of any of these pieces. I think one of the two or three things about this that we've been getting after that sets it apart, I think, from other ideas that are out there. The idea is that we'll do it, and the code for the puck is actually up on GitHub that Eric has already been working on and has put up on GitHub. If folks are interested, they can come to us and we can point them toward it. We want this to be open. We want this to be transparent. And we want this to be something that folks really around the world can work on together so that it actually is trusted and that it has integrity and that it's resilient, right? So folks can hack on it together and actually really try to break it. Um, that's a big part of what we're trying to do. And I think one of the other pieces is we've worked with folks at Galois who do formal methods to think about how to actually, prove that something does what it's supposed to do. And so getting to a point where with the code for the puck and the broker, so that we can run it through that sort of verification process is actually an integral part of this as well. Um, Lastly, I think one of the most important things, and this is what we've talked about with representatives from various states, is we have no interest in imposing this on somebody else. We'll develop it and then you take it and integrate it into your systems however you see fit. I'm not going to tell you what hardware to use. I'm not going to tell you how you need to build it into your architecture. Those are things that you can figure out. Therein, you would trust it even more because it's something that you had to figure out on your own how to actually do. We'll build the architecture. We'll explain to you how to do it, but then you can run with it. And I think that's an attempt on our part to kind of break with tradition a little bit. Like, um, in doing so, though, we'll build more trust and interest in participating by each of the states that are concerned.
The code is open source and states might be able to verify that the code does what it says it does. What about the hardware level? Could other states be worried that the hardware has been tampered with and that this system is therefore not to be trusted?
For sure. And that's one of the things that and this is just kind of a little bit to an extent of what I was just referring to. I think the idea is that states will take this and they can pick and use their own hardware. We've had that very frank conversation with a number of leaders from states that have nuclear weapons and have made very clear that we work with folks who are building fairly secure um, devices from the bottom up, but we wouldn't necessarily say that that's what you have to use. This would be something that you can take and you can integrate into your own system. You pick your own hardware so that you can trust it to the utmost degree. That's absolutely something that we talk about. Um, I think trying to impose some form of hardware on folks is just it's not going to go anywhere. So we really want to leave that up to the states themselves.
What prevents the CATALYNK system, from being implemented?
I think we've gotten a great deal of, so we now have a support and funding from the government of Switzerland and from the government of Germany. And we're very proud and happy to be working with them both on the political, but also the technical level, and extremely grateful for their support. I think the conversations by way of example that we had when we were up at the review conference for the NPT up in New York were incredibly encouraging in terms of the states that um, are supportive of this as a tangible example of risk reduction. The Really, it's just the hard work of speaking to those who would need to use it so that they get involved and move from kind of this idea prototype phase into its actual implementation. It is arguably less a technical question as it is more a political question. I think it's fair to say that, any state with nuclear weapons, as soon as you start talking to them about giving them communications capabilities that involve nuclear decision making, they're they're going to be somewhat incredulous, right? At the notion that what? So this NGO in California has come up with some device that I want to give the president to use in these situations. Well, yeah, that's the idea. And that we try to lever some of the capabilities of these technical communities to solve really what is kind of in my opinion, what is a market failure. This is not a problem that folks haven't known about. This has been a long-standing challenge that if you look back at some of the literature from the 1980s, I think it was in an edited volume that that Ash Carter and others put forward in 1987. This came up multiple times in there. How do you actually communicate in the midst of a crisis with your adversary when everything's being destroyed? We don't talk enough about that part of risk reduction. And so I think we've seen some great success in our conversations to date. I think honestly, the biggest thing between here and there is just continuing to galvanize support for it and get the support from the technical end to build it out, the rocks piece in particular, to build this out so that folks can turn to it and actually start thinking about how to integrate it.
Let's talk about the role of artificial intelligence in nuclear command, control, and communication systems. To what extent is AI being used today in these systems?
I think the literature that's out there around these things points to the use of um, technical capabilities that I think folks today don't even really think of as artificial intelligence, right? Going back decades for signals processing and um, data aggregation. There were tools that were deployed probably, I would argue, in the 70s that at the time were referred to as artificial intelligence, right? But folks wouldn't even think of it that way anymore. I think what you're more getting at is the kind of conversation around machine learning, deep learning, and its potential integration into these systems. There are all number of conversations around the relative merits of integrating these capabilities into nuclear command control and communications. And I think there was an article that came out uh, probably 2019, 2018 from Curtis McGibbon. Um, and I can't remember his counterpart's name. The the article basically made the argument that the United States needs to develop and deploy a dead hand system, right? So this uh, automated system that would be responsive and can launch a nuclear attack if a state were to be, decapitated and the messages could not get through, etc. And the thing that we um, spoke about at the time when that came out was to have two folks write that article who probably have been involved in related conversations in classified circles, right? What you um, almost have to assume there is that there are conversations around that sort of, there are debates around that sort of thing within classified circles. And so you begin to wonder, to what extent is it really being considered? And I think it's safe to say that at this point, at least to my knowledge, the uh, the considerations, I don't know, it's really very much opaque, right? I don't know the extent to which folks are moving down that path. But it gets to some of the questions that you were asking earlier in terms of that tightening decision cycle in which you need to be able to move quickly. And I think what's important here to think about, right, when you look at the signaling, for instance, again, we talked about it a little bit from the Russian side in terms of the capabilities they're discussing. Um, you look at what Russia talks about, you look at what China is signaling that its intentions are when it comes to command and control and artificial intelligence supported decision support systems, et cetera, that they're heading down that path in that they are looking for advantages to be gained by deploying machine learning capabilities, deep learning capabilities into all variety of command and control related subcomponents. And so there you are in that dynamic again, right? If the United States sees China heading down that path and it's not entirely clear where they are in their capabilities today, where they might be in a few years, you're almost being irresponsible to not head down that same path to figure out what you're capable of and what you may need to be doing in order to stay ahead and or deter another nation from getting ahead of you or putting you at risk. So, to your question, it's something that is, I think, getting a lot of attention or a lot of discussion. I think one of the pieces that we've pointed to is the discussion, at least the public discussion, has not been very specific it's been very broad, right? Artificial intelligence. Well, what are you talking about? Specifically, nuclear command and control and communication. Well, what are you talking about? Again, early in the conversation, I noted there's over 200 subsystems within the US NC3 system of systems. Where does deep learning even factor into that? Potentially. We've gone through the lists of the subcomponents that are at least publicly known. And I think there's a small, not small, it's not insignificant, the number of subcomponents that could potentially be enhanced by integrating machine learning capabilities in terms of signal modulation or what have you. I think there are definite advantages to moving down that path. I think what folks tend to think about is the automation of end launch decisions. So at this point, we have not seen any indication from the United States, by way of example, that they're heading down a path like that. Quite the opposite. They continue to publicly state and indicate that they will not turn those sorts of decisions over to machines. However powerful those machines become, that's a little less clear when it comes to Russia and China. To be quite honest, it's not as clearly stated, and some of their activities would point to otherwise. To be honest, so
And how
yeah,
could this be dangerous? So how could using AI in NC3 systems be dangerous? I'm thinking about these systems could be unreliable. They might be open to being hacked. Um, yeah, how could it be dangerous to implement AI in NC3s?
how much time do you have? It's a there's so many layers to the risks that are inherent to this, and I think um, absolutely for what you were just saying, there is that. And again, we talked about this earlier, right? Digital systems are almost inherently vulnerable, and I think folks out there working on AI red teams will tell you that machine learning systems inherit cyber vulnerabilities that have not been solved elsewhere, right? And so that is not something that can be easily dismissed or overlooked. I think you have to think about at a more strategic. And this is the way I've given lectures on this at UC Berkeley. Actually, there's basically three tiers of consideration you need to give this when thinking about the risk that it introduces: the strategic, the operational, and the tactical. Right. So we were just talking about the tactical level considerations that you need to put, which is perturbations. Like somebody's messing with a model and you're getting information out of that model that's telling you one thing that's actually completely not accurate. How do you actually deal with that in a system of systems that is so complex that you're not even entirely clear on what your system is? Right. So you're introducing a vulnerability, a layer of risk that is difficult to actually ascertain. That's technical, that's almost scientific at its core. Maybe you can get after the error rates that then compound within that stack and better understand it, and then have a conversation with your adversary about that. That's pretty tough just in and of itself, right? But then you start thinking about the operational level. These are incredibly tightly coupled systems, right? So what I mean by that, right, is that signal, decision, action has to be so tight that you don't really have time to stop and say, um, yesterday was Petrov Day, right? This is an individual who was receiving signals and warning through automated means telling him that there was an incoming ballistic missile attack from the United States. I forget what year this was, right? But Petrov said, no, that's incredible. That no way. There's no way that's happening. And he stood things down, right? Um, this is the inherent risk when you have systems that are so tightly coupled. There's going to be accidents. There's going to be errors. There's going to be false negatives. There's going to be mistakes. And when you introduce black box systems or systems that are incredibly brittle, or systems that are overfitted, or systems that, all these other problems that really haven't been figured out when these systems are in the wild, you begin to have operational level considerations of risk that even when it comes to like airline industry, they haven't entirely wrapped their heads around, or autonomous vehicles, writ large driving. I think there's a lot of emergent properties to those systems that folks never anticipated. That's something you need to grapple with. And then, of course, what we talked about earlier in the podcast in terms of the strategic level considerations. You are watching me, I'm watching you. The signaling that takes place and the credibility that's necessary with nuclear command control communications, that I am going to be able to do what I say I'm going to be able to do. I trust that you are. And if those things are inherently unsound and unreliable, that's inherently destabilizing. And so as we head down a path where these sorts of capabilities might be integrated into nuclear command and control, how do you actually create transparency? How do you actually create dialogue at a senior level so that folks can reduce that sort of strategic level risk? That's very, very difficult. So yeah, needless to say, the conversations that we've been a part of, it is often said that the benefits do not outweigh the risks. You haven't figured out the the answers to the problems enough to be able to head down that path, and it doesn't really give you that much more of an advantage in the end. But there are others who would argue against that and say that it does, that it actually gives you capabilities that are really beyond even our comprehension at this point.
You would definitely have to drive down the error rate of these automated systems to an unprecedented level,
That's right.
much, much lower than in self-driving cars, for example.
Yeah.
And we've seen that this is very extremely difficult to do. Um, yeah.
Yeah.
I would like to touch upon the conflict between Russia and Ukraine, because I think this is on the top of people's mind when we're talking about the risk of using nuclear weapons right now. What is your overall take on how this war has changed the risk of nuclear weapons use?
I think at its core, it's been deeply unsettling. As someone who has spent decades working with and around and on these sorts of challenges, when you think about nuclear deterrence and you think about the risk of nuclear weapons, how violent and catastrophically violent they are, um, I think we often lose touch with with the actual impact that the use of these would have, and we find ourselves in a generational shift where I think a lot of leaders and decision makers, even within the system today, seem to be increasingly inclined toward thinking about nuclear warfighting as an option. And that's deeply concerning because we're moving toward, in my opinion, we're moving toward a world with more nuclear weapons and more nuclear weapons states. Um, all of everything we've talked about here with NC3 today becomes all that much more important as you see a world with more states with nuclear weapons. What we've seen from the the, the really awful and almost abhorrent, not almost, absolutely abhorrent situation in Ukraine is this is one of the real longstanding um, challenges when it comes to just having nuclear weapons and the deterrent purpose that they're supposed to serve. And what we've seen is Russia's willingness, quite honestly, to break a number of longstanding norms that it had been committed to, i.e., nuclear assurances for Ukraine, that having given up its nuclear arsenal, that it would not be put at risk like this. What does that signal to other states that are considering moving down this path? Russia's willingness to talk about, and now they're in the motions of going through these referenda and annexing Ukraine's territory, so that, once that's done and they say that that's part of Russia, now they will say that attacks against that territory could result in a nuclear response. That is, this is beyond, I think, what anybody would have accepted even just a few years ago as acceptable behavior. It's an incredibly risky and dangerous dynamic, and it's moving the world in a direction, honestly, that I never in my life thought that I would see. It's inherently unsettling, to say the least. And then you see Russia going even further, putting a nuclear power plant basically in the middle of an armed conflict and using it, um, basically as blackmail, a massive potential radiological weapon, you know, almost in the heart of Europe, is reckless beyond, uh, almost beyond imagination. So yeah, um, I think it definitely increases the risk. All of that being said, again, as someone who's spent a lot of time around these things over the years, maybe, just maybe, this sort of reckless, irresponsible state behavior will result in positive outcomes. Maybe this will actually motivate people to change some of the trajectories that we've been on. Maybe this will actually point to the need to have greater constraints in place. Maybe this will actually galvanize international actors to uh, move more collaboratively toward making clear that this sort of behavior is just absolutely unacceptable. Right. So you think about, I hate to say it, you think about the China Taiwan dynamic. And what does this scenario mean for that? I think it's the opprobrium and absolute disgust and rejection of Russia's actions in Ukraine by the international community that matters. That speaks volumes to the leaders and decision makers in Beijing. And so it is an incredibly critical situation. I I don't think I know. Well, anyone who tells you they know what Putin is going to do is lying. I don't think anybody really knows what's going to happen or how much he means it when he says he'd be willing to use a low yield, tactical nuclear weapon in Ukraine to advance their objectives. Um, Hopefully this has positive outcomes, but at the end of the day, I think as Putin continues to see, as many have said, as President Putin sees increasing losses and setbacks on the ground, that is an unacceptable outcome for him. It leaves him with very few options. And so this is where, the National Security Advisor has his has his work cut out for him in advising President Biden on what decisions to take and how far to push and how to make sure that we don't go too far and push this clearly embattled leader into a corner to the point where he needs to make really horrible decisions to deploy and use nuclear weapons. If he did, I don't know that any of us understand just how much that will change our world.
How critical is the situation right now compared to, say, the Cuban Missile Crisis?
Um, Very different dynamic, right? I think the lines of communication are in, as far as we can tell, very open between the US and Russia, that those messages that we're sending are getting through. Whether or not they're being heard is a completely different thing. Um, I think the fact is that, um, in that instance, in the Cuban Missile Crisis, that would have resulted in very quickly catastrophic nuclear use. I think in this situation, you don't necessarily see that. You're going to see, if Russia were to actually move down the path of using perhaps low yield nuclear weapons against Ukraine, the response from NATO, the response from the United States and NATO, I don't know that it would necessitate a nuclear response, whereas an attack on the United States would, right? So it's a little bit of a different dynamic. However, horrifying and uh, and escalatory that would be. The escalation ladder in that scenario is not anything anyone has ever actually had to live through, right? We don't know. Yeah.
It's an unknown situation. It's a situation the world has not been in before.
So it's the imperative is upon our leaders to take all of the inputs that they have, and hopefully they're not relying on a brittle uh, predictive analytics platform that is telling them what to do. Right? Yeah. This goes back to the risks of embedding, you know, automated decision making support systems into your nuclear command and control. You want to be able to really retain that human element in this sort of scenario to think about ways to find de-escalation paths. Yeah.
Philip, I can't say this has been a happy conversation, but it's been very informative and scary also. Thank you for talking with me.
Absolutely my pleasure. Thanks for having me. Lots of work to do.
That's it for this week's episode. On next week's episode, we'll be looking into how combining artificial intelligence with nuclear command and control systems could be dangerous, and we'll be looking into concrete scenarios for how this could increase risk.